Hi, welcome to Wisdom Analysis, the place where we make chemistry easy and fun. So, on today's episode of the Jamb series, we are going to topic 4. So, that is topic 4A. I'm going to make it in 3 parts. Topic 4A, so that's what we're doing today. So, this is your Jamb syllabus. We're going to be doing this area of the course.
Okay, so what is an atom? An atom is the smallest particle of a substance that is capable of going into a chemical reaction. Okay, so you see hydrogen. So just writing the alphabet H represent one atom, adding 2, there's 2 atoms, and this is 3 atoms, and so on and so forth. So in a compound like this, there is sodium hydroxide. You can see that one atom of each element is a list that can go into a chemical reaction. Now, what's a molecule? A molecule is the smallest particle of a substance that is capable of independent existence. Okay, so you can see hydrogen now. One atom of hydrogen cannot exist alone, so it needs 2 atoms to exist on its own. So this is called a molecule of hydrogen. Okay, so now we have monoatomic compounds. That is compounds that have only one atom to form a molecule. Does not need 2 atoms to exist on its own. We have potassium, sodium, aluminium. For the diatomic ones, that is, it needs 2 atoms to be stable on their own. That is hydrogen, oxygen, chlorine, nitrogen. For triatomic, we have oxygen. Oxygen can be triatomic, forming ozone. So that is actually ozone here. Tetraatomic, that is phosphorus, and polyatomic for sulfur. Okay, so for compounds, if you just write the formula of the compound, that is one molecule of the compound. So if you add 2 to the side, that is 2 molecules, okay? And if you add 3 and so on and so forth. Now this is 3 atoms coming together to form the compound. So it's called a triatomic compound. 2 atoms of sodium and 1 atom of oxygen, so it's triatomic. Hydrochloric acid, 1 atom of hydrogen and 1 atom of chlorine, that is diatomic. For this is 1 atom of bromine and 3 atoms of hydrogen, so it is tetraatomic. Okay, so your quest: state one example each of diatomic, triatomic, tetraatomic and polyatomic compounds. Your own examples. Please leave them in the comment section. Okay, so what are ions? These are atoms or groups of atoms that carry charges. As you can see on the screen, they all have different charges. So how do they get their charges? You know, atoms have neutrons, protons and electrons. The neutrons and protons in the nucleus and the electrons in shells. Now the protons are positive, the electrons are negative. Now in a normal neutral atom, the number of protons are equal to the number of electrons, making the total charge to be 0. So if it loses 1 electron, this -7 will reduce to -6, and now the total charge will be +1. So if it loses 1 electron, it forms +1. Now if it gains 1 electron, now this was -7 before, it gains an additional electron, which will be -8. So the total charge will be -1. So if it loses 1 electron, the total charge becomes +1. Loses 2, the charge becomes +2. If it loses 3, the charge becomes +3. Okay? If it gains 1 electron, total charge becomes -1. If it gains 2 electrons, total charge becomes -2. If it gains 3 electrons, total charge becomes -3. So if it gains, it is minus. If it loses, it is plus. So you can see that the atoms on the left have lost electrons and the atoms on the right has gained electrons. So the positive atoms are cations, the negative atoms are called anions. Okay, so let's go to atomic structure. So this is what an atomic structure looks like. The protons and the neutrons are in the nucleus of the atom, while the electrons are in the shells. So these are the shells, okay? Now this is what a hydrogen atom looks like. See, it has
1 there as the atomic number, which is the same as the number of protons, and also 1 as the mass number, which we'll talk about shortly. So the number of protons is also equal to the number of electrons in a neutral atom. So that's why we have 1 electron here in its structure. So if it loses 1 electron now, it has 0 electrons and only 1 proton, so it will be +1 as its charge. These protons are positive. Now let's go to helium. Helium has 2 protons, which will make 2 electrons since it is neutral. Okay, so lithium is 3. The 3rd electron goes to another shell because the first one is full. Now beryllium is 4, so 4 is like this. Boron 5. Then we move to carbon, which is 6. Then we move to nitrogen 7. We move to oxygen 8. We move to fluorine 9. And now we move to neon 10. We also move to sodium 11. You can see that the second shell is also full, so it moves to the next shell. The first shell is called K, second shell is L, and the third shell is M, and so on and so forth. Now the first shell can only contain 2 electrons and the second can only contain 8 electrons. So how do we know? Well, here's the formula to know that. Okay, so the maximum number of electrons in the shell is given by 2n raised to the power 2, where n is the shell number, K for 1, L for 2, and M will be 3. So for the first shell we use 1, 2 times 1 square, which will give us 2. For the second shell we use 2, 2 times 2 square, which is 2 times 4, which will give us 8. Now for the third shell we are going to use 2 times 3 raised to the power 2, which will give us 2 times 9, which is equal to 18. And same for further shells as we move on to N, O, P, and so on. So for N, it is 4, 2 times 4 square, 2 times 16, which will give us 32. Okay, so we move over to atomic mass. So the atomic mass is the number of protons plus the number of neutrons. Okay, so you can see sodium now. Its atomic number is 11, which is same as the number of protons, and the mass number is 23. So since mass number is number of protons plus number of neutrons, what's the number of the neutrons? You can clearly see that 23 will be equal to 11 plus 12. So 12 is the number of neutrons. Okay, so generally the mass number is represented by A and the atomic number by Z. Okay, so let's go to isotopes. These are atoms of the same element but having different masses. So you can see chlorine 35 and chlorine 37. They have the same atomic number, which is 17, but different masses, 35 for one and 37 for the other. Now you can tell me the different mass number is as a result of the different number of neutrons. So since they both have the same number of atomic numbers, the first have 18 as its neutron, making it a total of 35, and the second has neutrons of 20, making a total of 37. So that's why their mass numbers are different, but they are still of the same element because they have the same atomic number. Okay, so let's go to the relative atomic mass, that is the general atomic mass of these two isotopes. So if they say one of them is 75% and the other is 25% of a given sample, then you do 75% times the mass number of the first one and 25% times the mass number of the other, which is 25%. So you add both of them together and that will give you, this is 26.25 and this is 9.25. If you add them together, that will give you 35.5 as the relative atomic mass of the isotopes. So let's go to atomic theory. J.J. Thomson. In the year 1897, the physicist Joseph John Thomson, popularly known as J.J. Thomson, discovered the electron. Robert Millikan. In the year 1910, the physicist Robert Andrews Millikan discovered the magnitude of the charge of the electron. James Chadwick. In the year 1932, James Chadwick discovered the neutrons. Ernest Rutherford. In the year 1909, Rutherford discovered the protons. Henry Moseley. In the year 1913, Moseley discovered a method of accurately identifying the element's atomic number by radioactivity. Niels Bohr. In the year 1913, Bohr discovered the electrons orbit the nucleus in shells. John Dalton. In the year 1808, John Dalton proposed the Dalton's atomic theory, which goes as follows. Number 1. All things are made up of indivisible particles called atoms. 2. Atoms can neither be created nor destroyed. 3. Atoms of the same element are alike and different from atoms of every other element. 4. All chemical changes and reactions result from the separation and addition of atoms. And 5. Atoms combine in simple whole number ratios to form compounds. But the first law, which says that atoms are indivisible particles, was taken away by radioactivity. As we all know, atoms are made up of the neutrons, protons, and the electrons, which can be separated by radioactive means. So you can see that you can divide atoms. Now, the second law, which says that atoms can neither be created nor destroyed, was also taken away by radioactivity, a process whereby you can form new atoms from past ones. Now, atoms of the same elements are alike and different from atoms of every other element. Now, isotopes took it away, that is, atoms of the same element or different masses, then that does not make them alike. Now, all chemical changes and reactions result from separation or addition of atoms, and this is still valid. Atoms combine in simple whole number ratios to form compounds. For normal compounds like this, it is true, but for organic compounds where atoms can go up to 16 and 34 and even higher numbers, kind of struck it out. Thanks for watching the video. If you love the video, don't forget to hit the like button so more people can see this video, and leave comments on whatever you don't understand or any questions you want to ask. I'll be glad to answer them. And also subscribe if you're not subscribed to the channel. Alright, see you in the next video. Bye.